Okay, hello. So today we want to look at differentiation of trig function cos x. Now last lecture we dealt with that of sin x. Okay, so we go through the same procedure, right? We know that f prime of x is the limit as the s tends to 0 of f of x plus delta x minus f of x all over delta x. So we have become so familiar with this formula right now from the first principle, right? Okay. So now our cos x is now going to be replaced by this right now. So it's now going to be the limits as the x tends to 0 cos x plus delta x minus cos x over delta x. Just as we derive for that of sin x. This is cos x dx minus cos x. It's addition. We can convert addition to products, using our formula. So let's just quickly derive the formula for those who don't know. Cos A plus B is cos A cos B minus sin A sin B. And cos A minus B is cos A cos B plus sin A sin B, right? So if we subtract the two, that's going to be cos A plus B minus cos A minus B. So that's going to be, now you subtract this from this. This and this will be gone. Then this is minus sin A sin B minus that is minus times plus. That's minus. So minus sin A sin B minus sin A sin B, that will be minus 2 sin A sin B minus 2 sin A sin B. Okay? And we know that if we replace this A plus B by C and A minus B by D, right? So what are we going to get? What are we going to get? If we add them, 2A will be C plus D, right? And A will be C plus D all over 2. Then 2B, when we subtract them, that will be C minus D, and B will be what? C minus D over 2. Right? Okay? So from here now, we will now do what? We will now put these values into this identity here. Right? So that will be cos C minus cos D will be minus 2 sine C plus D all over 2, right? Sine C minus D over 2, right? Okay? So that will be the identity that we are going to use to replace this. Okay? Okay. So now our f prime of x is now going to be the limit as delta x tends to 0. Okay? So let me check it. Okay, so when we now replace this with C and this one as D, then that becomes what? Cos that minus 2 sine C plus D, that will be x plus delta x plus x, right? This all over 2, right? Then sine x plus delta x minus x all over 2, right? Do we see that? So all over delta x. Okay, so that's going to be the expression now. So this minus this, that will be 0, right? So this becomes a limiting value as delta x tends to 0 minus 2 sine 2x plus delta x all over 2. Then sine here becomes delta x over 2. right? Delta x over 2. All right. Then divided by delta x. Okay? So this delta x, we can divide it by 2 and also multiply it by 2. Right? So that it will be similar to this. And we can apply the limits. The limit of a tending to 0 of sine a over a is equals to 1. We know this identity. Right? So we want to construct this to be in that format. Right? So that will be the limit as the x tends to 0. This is going to cut this. Now half minus sine half of 2x plus delta x. Then sine delta x over 2 all over delta x over 2. The limit can be applied to each of these components separately, right? You can do that. Application. So that will be limit as delta x tends to 0 of minus sine 1 all over 2 2x plus delta x, right? So we apply the limit on this one. We also apply the limit on this one of sine delta x over 2 over delta x over 2. Okay, so this is now going to be, when we apply the limit on this one, we introduce 0 to this one, so it becomes minus sine 1 all over 2 2x, right? This becomes 0. Then this becomes 1, right? So when 2 cuts 2 here, becomes minus sine x. So minus sine x is now the derivative of cos x. So anytime we are asked what is the derivative of cos x, it is what? Minus sine x. Okay? So that's how we go about that. Okay? Thank you.